We are talking about circle and circumference and measuring angles and arcs. And here are a couple example problems that we're going to work with, and we want to solve for all missing arc measures. So right away when we look at it, we can see that we have two arc measures that are given. We know that DE is 90 degrees because of this mark right here. So we know that the measure of arc DE is equal to 90 degrees. Also, another piece of given information is the measure of arc AE. That is 63 degrees, and that's from the given information. Now, because these are vertical angles here, we know that this angle, angle AFE, is congruent to this angle BFC by vertical angles, so this is also 63 degrees. So the measure of the arc BC is also equal to 63 degrees. So another one we can look at is AB. And one thing we notice is that there is a semicircle, which is ABC, or 180 degrees. So the measure of arc AB is going to be equal to 180 degrees, because that's the semicircle, minus 63 degrees. So the measure of arc AB is equal to 117 degrees. So we have one arc left to check, and that's 90 degrees there. We have the arc CD, and CD we can also get because we know that arc BCE is also a semicircle, because there's a diameter that goes straight through F and connects to the outside. So we can say the measure of arc CD is equal to 180 degrees. Then we can say minus 90 degrees minus 63 degrees. So then we can get the measure of arc CD is equal to 27 degrees. And then one quick way to check to make sure is if you add all these up, they should add up to 360 degrees, because that's all the way around the circle. We can look at our next example over here, and we're given two of the arcs. We're given QR and we're given NP. We also know that because of vertical angles, we know that ROQ is congruent to NOM. So we can say QR is congruent to MN. So then we know arc MN is equal to 73 degrees. Now we can look at MR, and again we can see that NR is a diameter that goes through O. So NMR is a semicircle. So we can say the measure of MR, that's right there, that's going to be equal to 180 degrees, because that's the full amount of a semicircle, minus 73 degrees. So the measure of arc MR is equal to 107 degrees. So as we look, we can see that we have most of the circle accounted for. This is 107 degrees right here. So then we still need to get PQ, and we can find PQ the same way that we found MR, because NPR is a semicircle, because NR is a diameter. So we can say 180 minus 81 minus 73, and that will give us our remaining arc measure. So measure of arc QP, that's going to be equal to 180 degrees minus 81 minus 73. And so we use our calculator and we get the measure of QP, of arc QP, is equal to 26 degrees. Now we can look at example 2. And we have line segment AC and line segment BD are diameters of circle Q. Identify each arc as a major arc, a minor arc, or semicircle of the circle, then find the measure. So first example we have is measure of, so AE is right here, and we can tell that that's going to be a minor arc. So AE is a minor arc. Next we're going to look at is EDC. EDC, that's less than 180 degrees. So EDC, that is also going to be a minor arc. Then next we have measure of ABC. We can put our arc measurement symbol over these. So we're talking about arcs. So next we're talking about the measure of arc ABC. ABC, and that is exactly, we already said AC was a diameter, so ABC has to be a semicircle. So because it's a semicircle, we automatically know that the measure of that angle or that arc is 180 degrees. Next, we can look at AB. AB is also going to be right here, and that is going to be a minor arc. And then measure of ADC, again, AC is a diameter, so ADC has to be a semicircle. So we know that the measure of that is going to be 180 degrees. And our last one we have is BC. BC is right here, and that one's given. That is 100 degrees. So that is a minor arc. And the measure of arc BC is equal to 100 degrees. So we have 3 of the 6 arcs measured. We have to be able to come up with the last couple. So here is AB. You remember AB is part of that semicircle that already has 100 degrees included. So we have to calculate this last arc by subtracting 180 minus 100. So we can say 180 degrees minus 100. So that tells us that we have a measurement of 80 degrees. So we have a measurement of 80 degrees for AB. That also means that over here, arc DC is also 80 degrees because those are vertical angles. But we don't have DC as one of our options. We do have EDC. So to get that whole measurement, all we have to do is add the 2 angles together, or the 2 arcs together. So 50 plus 80, and that will give us our angle measure. So 50 degrees plus 80 degrees. And that is going to be equal to 1 degrees. And our last one, AE, is right there. So BD is a diameter and AC is a diameter. So our angle our angle in our arc right here has to be congruent. So this one is 100. This one is also 100, but we've already used 50. So we can take 100 minus 50, and that will give us our remaining amount. And so we have a remainder of 50 degrees. A couple more to practice. Name any minor arc. One minor arc that we can name is going to be arc BC. BC is right here. So that's a minor arc because it is less than 180 degrees. Name a major arc. A major arc that we can name is BCA because that definitely goes over 180 degrees. So we can name that. There's a lot more that we could name, but we can see that we keep going around and around and around. And we go past 180 degrees. So BCA is going to be a major arc. Arc BCA. Name a central angle. A central angle we can say is angle DPE. Angle DPE. So the difference between a central angle and an arc is the central angle has to include the center point. So we had to keep that included. And then name a semicircle. Well, the only semicircle we have right here has to include BE. So we could call it BCE, or we could call it BAE. Either one will work. We'll go BCE. And the reason that B and E have to be on the outside is because those are the only 2 points that are connected to the diameter. Then we have a couple measurements to calculate. It says calculate the measure of angle BCP. So BCP, and as we can see, it's written right on there, is 51 degrees. So the arc, the measure of an arc and the measure of the central angle are the same. So it's 51 degrees because it's written right there. Then it says find the angle of APE. So we have APE, APE. So the way that we'll have to calculate this one is because this BE is a diameter, we know that BAE is a semicircle. So that means that that's 180 degrees. And we already were given that's 98 degrees. So we can say 180 minus 98 degrees. So for our F calculation, we can say the measure of angle APE is equal to 180 degrees. That is the measurement of a semicircle. And then we can say minus 98 degrees because that's what's given there. So minus 98 degrees. And so we get the measure of angle APE is equal to 82 degrees. Then we have the measure of arc CDA. I think I was saying, yep, the measure of arc CDA. Can add our arc on there. CDA. So we just calculated that this was 82 degrees. And we can see that that's 19 degrees. So we just need to figure out our remaining angle here. So we have 51, 98, 82, 19. And we just have to figure out our last portion there. CDA. So the whole thing, the whole circle is 360 degrees. So we're going to calculate G. The measure of arc CDA is equal to 360 degrees because that's the full circle. And we're trying to find from C to A through D. So there's only 2 parts that aren't included in there. That's the 51 and the 98. So we're going to subtract those. So we're going to subtract 98 degrees, and we're going to subtract 51 degrees, and the remainder will be the measure of arc CDA, which is going to be equal to 211 degrees.